Welcome to our series of short technical discussions. It's all about rope. In this edition, elongation. We'll discuss how the length of synthetic ropes can change when put into service, and how the different forms of elongation can affect both the selection and the performance of your rope. The Cordage Institute defines elongation as the ratio of the extension of a rope under an applied load to the length of the rope prior to the application of the load. It is typically expressed as a percentage. Why would elongation be important to consider when selecting a rope? Let's look at a few situations. When you moor a vessel, whether it's a small personal craft or a supertanker, the mooring lines need to be able to stretch with sudden changes in loading, like the surge from storm waves. Without a little stretch or elongation in the mooring system, that sudden loading can result in significantly higher dynamic loads that may damage lines or associated hardware. Large vessels using high-performance mooring ropes with little elongation intentionally add tails to the lines to increase the elongation of the whole mooring system. When lifting or lowering, or while towing heavy loads, a rope that elongates too much can compromise control over the load and increase the distance from the attachment point. Both are potentially dangerous situations in complex operations. In these cases, low elongation rope should be selected with the highest possible strength within the limits of the application. On the other hand, a window washer on a platform high above street level wants his vertical safety line to stretch in the event of a fall. Here, elongation acts to mitigate the shock of arresting the fall. Without sufficient elongation, that shock could result in severe injury to the worker or damage to the attachment point. Neither is a desirable outcome. When a load is applied to a synthetic rope, it elongates or stretches. The amount of stretch depends on both the rope's construction and on the fiber or fibers it is made from. In general, for synthetic ropes made from the same fiber, twisted ropes stretch or elongate more than braided ropes. As for fibers, nylon is among the stretchiest of fibers used in making ropes. High-performance fibers like HMPE, high-modulus polyethylene, and aramid are among the lowest elongating fibers, with rope elasticity similar to steel wire. Samson provides information to help you select the right rope for your application. The elongation chart compares the elongation of several typical fiber types used in synthetic ropes. It shows that, in general, nylon ropes have the greatest amount of elongation. Ropes that combine two fibers, like nystron, a combination of polyester and nylon fibers, have reduced elongation compared to all nylon ropes. And all polyester ropes, like stable braid, have even less elongation. Amsteel Blue, a rope made from 100% Dyneema HMPE fiber, has ultra-high strength and exhibits even lower elongation. All ropes, whether made from natural or synthetic fibers, even wire ropes, elongate to some extent when put into service. There are several components of elongation, and we'll discuss each of them in turn. Elastic elongation is that portion of the stretch that's recovered immediately after the load is removed. Hysteresis is the amount of elongation that is recovered over time after the load is removed. Permanent extension, that portion of the elongation that will never be recovered regardless of whether the rope is loaded or not. We'll also discuss two components of permanent elongation: constructional elongation and splice setting, and address the role creep plays in permanent elongation. Here's what happens when a rope is loaded. It's a good illustration of the components of elongation. First, the rope immediately elongates or stretches to a new length. When the load is removed, a portion of the rope's extension is immediately recovered. This portion of elongation is called elastic elongation. The next component of elongation we observe is hysteresis. This is the portion of the extension that is recoverable over time. In the course of a few minutes, hours, or even days, the rope will recover some of the extension remaining after elastic elongation has been recovered. What remains is called permanent elongation. There are two main components of permanent elongation: constructional elongation and splice setting. For most ropes, the vast majority of constructional elongation occurs when a new rope is initially placed in service. The fibers compact as the strands align and adjust. Minor helical changes of the braid angle also contribute to the total constructional elongation and diameter reduction. Splice setting also contributes to permanent elongation. Splicing procedures disturb the braid of the rope. Upon the first loading of a newly spliced rope, there will be the same kind of realignment of the fibers, strands, and yarns of the rope while it compacts into its final position. This effect can be more pronounced on shorter ropes fabricated with spliced eyes. Constructional elongation and splice setting generally occur in the first few cycles of loading on new ropes. On subsequent loadings of the same rope, the magnitude of constructional elongation and splice setting will be diminished on every cycle of loading. In reviewing the specifications before selecting a rope, you may have noticed a small table of data labeled elastic elongation percentage. These numbers, determined through extensive testing, represent the amount of elongation you can expect from that rope after it's been bedded in, after construction elongation and splice setting have been removed. Creep. While a comprehensive discussion of creep properties is beyond the scope of this presentation, it bears mention. For some synthetic ropes, permanent elongation and creep are mistaken for the same property and are used interchangeably, when in fact, creep is only one of the mechanisms that can cause permanent elongation. Creep becomes a factor only when a combination of specific circumstances are present in the application. Creep is a material's slow deformation at the molecular level that occurs while under a static load over a long period of time. Creep is mostly non-reversible and is a result of the combination of the load, time, and temperature. Each fiber has its own specific creep properties, and each application should be assessed for the potential of elongation due to creep. If the application calls for static loading at high percentages of the rope's breaking strength that remains constant for very long periods of time, months and years, as opposed to minutes, hours, or even days, particularly at elevated ambient temperatures, creep should be accounted for in the design and long-term planning of the deployment. Fiber producers have developed new fibers that have enhanced resistance to creep and tools to help assess the potential for creep based on the application's specific characteristics. When supplying ropes for critical applications where elongation and length tolerances can have an impact on performance, contact your Samson representative. Samson engineers have developed tools, techniques, and models for predicting our rope's behavior under a variety of circumstances and situations. Thanks for watching this installment of It's All About Rope. If you'd like to know more about elongation, visit Samson's website at samsonrope.com. There, under the Resources and Literature pull-down menu, you'll find videos, technical bulletins, articles, brochures, catalogs, case studies, and more on a wide variety of subjects concerning rope use and maintenance. Of course, you'll always find full product specifications, a dealer locator, and information about Samson products in many different applications. And for those on the go, the Samson app also includes links to videos, the PDF versions of many of Samson's splicing instructions, and a full version of the Samson Inspection and Retirement Guide, complete with a visual comparator for assessing abrasion. It's available as a free download through iTunes. Thanks for watching this edition of It's All About Rope.